The class today is going to be very short. It's not going to be long. And we are going to have a discussion on the Amdahl's law. And what is Amdahl's law? And how can we use Amdahl's law to implement the things we need to implement and do the things we need to do? How are we going to use and utilize Amdahl's law to do them? Okay. Now, I have to ask a question to the class, and anybody can answer it. Just raise your hand, and then you can answer it. Over here, I have a scenario. So in here, I want to chop vegetables. So I have vegetables in which I want to chop. Now, if I chop the vegetables, if I do it alone, it will take me 30 minutes to do it. It will take me 30 minutes for me to chop the vegetables. Okay? So, ladies and gentlemen, how can I do this faster? Who can help? If I want to chop these vegetables faster, how can I chop these vegetables faster? Who can help? Yes, John.
By adding water.
John, do you know what a vegetable is?
Yes.
John, are you sure you know what a vegetable is?
Yes, I know.
But John, if you want to chop vegetables and you want it to be versatile, you have to add water.
Yeah.
John, so you're telling me that if I want to cut cabbages, if I add water, I can cut the cabbages faster.
He said chop.
Chop means cut. So I'm cutting vegetables.
Okay.
And you're telling me that in order for me to cut vegetables, I should add water.
The chop, I thought like you eating it.
Like
chopping.
No,
I thought like chopping, like eating.
John, chopping has never been eaten. It is the boys in the area that call chop eating. No, it's not that one. Okay. So chopping here means cutting. I'm trying to cut vegetables. So if I'm trying to cut vegetables,
they get help from others.
I get help from others. Very good. How much help do I need?
Probably like 2 or 3.
2 or 3. Okay. Very good. So if we're 3 people, maybe to take us 10 minutes to cut the vegetables. Very good. So that is the answer in which I was looking for. Now, if I am supposed to bake a cake, if I bake a cake in an oven, it takes me 1 hour. How many do I have to, how can I make this process faster? The baking of the cake.
Get more hands on deck, people to help you.
Okay, but if I get more hands on deck, me putting the cake in the oven, will it make the cake bake faster?
Okay, you get more ovens too.
If I have 1 cake, if I have 3 ovens, will it make that 1 cake bake faster?
No, it won't.
So how will I do it? Yeah, some very interesting things.
Please, you have to increase the fire.
The temperature. Increase the fire.
Yes, please.
Have you people baked a cake before? Have you seen a cake being baked?
It will get bent.
It will get bent. If I increase the fire, the cake will get bent. So for the cake,
increase the number of ovens.
Listen, if I increase the number of ovens, how the cake will it enter all the ovens? It only enter 1 oven, or
nothing can be done unless you exercise patience.
Nothing can be done. Hey, Charlie, the boy who said that I have to give him 5 marks. Nothing can be done. Do you understand?
Should I drop the Momo now?
And I have to give him 5 marks. And also, let's drop the Momo number. Hey, Rade. Oh my God.
Maxwell,
very good. I saw the name Maxwell. It is you, yes. 5 marks have been dedicated to you. Because obviously, nothing can be done. Nothing can be done. We can't do anything. Then nothing can be done because the cake will have to go into the oven at a certain temperature for 1 hour. We can't do anything. But in the first scenario, we can do something. In chopping the vegetables, we can cut it faster. If we add more people, we can finish earlier. Now, in a computer, there are certain parts of the computer that cannot be improved. If it takes 3 hours to do what it has to do, you will have to wait for 3 hours. There is nothing you can do. And there are some certain parts of the computer in which you can increase them. Now, the question is, if I increase a particular portion of the computer, how much improvement will it give my computer? And the improvement it will give my computer, by how much? What is the monetary amount that will that improvement cost me? Let's look at it from this point of view. We are saying that Amdahl's law is a formula used to understand how faster a task can be completed when you improve part of the system. For example, if I had a computer, let's say I worried my mother and my mother was able to go and buy a computer for me. And the computer in which my mom bought for me is a 4 gig computer. So I have a 4 gig computer. Now, this 4 gig computer in which I have, it has a 1 terabyte HDD in it. So it has a 1 terabyte hard drive in it. Now, this computer in which I have gotten, I can upgrade it. What can I upgrade? I can upgrade the hard disk. So I can make it an 8 gig hard disk. And I can maintain the 1 terabyte HDD. Amdahl's law is looking at something very important for us. Amdahl's law is asking us a simple question. One, if I change my computer from 4 gig to 8 gig, how faster will my computer be? Will it be 50% faster? Will it be 60% faster? Will it be 80% faster? How faster will it be? Note that the hard drives was maintained. So the definition, look at the definition again. Amdahl's law is a formula used in computer science to understand how much faster a task can be completed when you improve part of the system. So when I improve one part of the system, the RAM, how faster will my computer be? So if I come to you as a computer scientist, as a data scientist, as an analyst, and I ask you, oh, I want to improve my computer. I want to go and buy 4 gig and add it to my 4 gig so I get 8 gig. Should I do it? And let's say that if I do it, my computer is going to improve by 50%. As an analyst, what will you tell the person? Oh yeah, you can go and do it. But if, let's say, for me to go and change add a 4 gig to this, the 4 gig will cost me, let's say, 450 Ghana cedis. It's me spending 250 Ghana cedis. A good idea if my computer will only improve by 50%. Oh, 250, 50% is okay. Now, let's say that another person who also has 8 gig goes to buy a 1 terabyte SSD. And this would improve his computer by 80%. But the SSD will cost him 1,000 Ghana cedis. Now, 1,000 Ghana cedis for 80% improvement in the computer, does it make sense? Oh, it makes sense. So 1,000 Ghana, Charlie, brand new computer is like 8,000. So 1,000 Ghana, they go and do. Oh, okay. Now, let's say we have another person who has this computer, 8 gig, 1 terabyte SSD. And he goes to buy 16 gig and add it to the 1 terabyte SSD. And this will improve his computer by 20%. But the 15 gig in which you have to go and buy is 500 Ghana cedis. That doesn't make sense. My job is not to tell you if it makes sense or if it doesn't make sense. That is not why I'm here. My job is to teach you how to calculate the percentage improvement when I change a particular component in the computer system. When I change a particular component, how much improvement will I get? Are we clear? Any questions? Do we have any questions?
No, please.
If there are no questions, then let's proceed into discussing the Amdahl's law. Let's proceed. Amdahl's law is a formula used to find the maximum possible improvement in an overall system when only part of the system is improved. It's especially relevant in parallel computing, where it predicts the theoretical maximum speed up of a program that can be partially parallelized. Suppose you enhance somehow your machine to make it faster. Therefore, speed up is defined as the old time over the new time. So if I have a computer, the time I get for when the computer has not been improved, if we're using this scenario, I will time the computer over here doing something. Let's say it does this thing in 1.75. Then I'll time the computer doing this thing. Let's say it does it in 1.45. So we are saying that speed up is equal to 1.75 over 1.45. I'm done. Now, this is me calculating speed up based on the execution time. If I wanted to calculate speed up based on the performance, the ability for the thing to do something, then it is my performance with the enhancement over my performance without the enhancement. That is, if I'm looking at it using performance, then it is the performance after enhancement over performance before enhancement. If I'm looking at it using time, then it is the time before enhancement over the time after enhancement. So they are reciprocals of each other. So in a question, I can give you performance. If I give you performance, I'll give you the performance before and after. And you should know that after comes on top of before. But if I give you time, I'll give you the time before and after. And you should know that the before comes before the what? After. Based on what you use, that will determine how you calculate speed up. Now, this is speed up when I am making a wholesale change. But we don't make wholesale changes. We make changes based on particular portion. For example, over here, I have my hard disk set. I'm only changing my RAM. Here, I'm only changing my RAM. Over here, I'm changing my hard disk. Over here, I'm changing my RAM. I will only change one part. The whole system is there, but only one part of it is going to be changed. So if I'm changing only one part, how do I calculate the changes that have gone on in one part? I would use the formula on the screen. How is the formula on the screen? The formula on the screen can be written like this. One second. One second, please. It can be written like this. Voila. So what is this? They said the speed up is equal to 1 into bracket 1 minus P plus P over N, where P is the proportion of the program that can be serialized, the proportion of the program that we can grow. For example, if I come in this question here, I'm saying that suppose you have a machine used in I/O intensive environments. That is, you have a computer that is very intensified in displaying things and receiving inputs. Okay. The CPU works for 75% of the time. So here, you can see that the CPU is working 75% of the time. 75% of the CPU's time is spent doing a particular job. The rest of the time is used in waiting for I/O operations. That means that the portion of the computer that I can change is the portion of the computer that is working. The one that is resting, I can't change. So over here, P is represented by 75%. That means that the portion in which I can't change, in which nothing can be done with it, is 1 minus P. That means that if I'm going back to this question here, the portion I can change is 75%. Therefore, the portion I cannot change is 25%. That means that over here, I'll do 1 minus 75, which would give me 25%. Then the N is the number or the factor of improvement. If I come to the question over here, they are saying that you may consider an improvement of the CPU by a factor of 2. That means that if I am supposed to do whatever I am doing, my CPU will run at a factor of 2. In English, we would say it will run as twice as fast. So in every question you'll be given, the factor or change, the amount of people you have added, the amount of improvement you have gained is what you place as the value of N. So in the scenario I gave you about the chopping of the vegetables, you see that over here, the portion in which I can change is the vegetable, because it's only the vegetables I can add people. If the baking, I can't add anybody. If I have a system, the baking part, I can't add anybody. It's okay. The portion in which I can do something with, I'll do something with that. Now, the amount of improvement that I am going to do is the N. This same formula is what I have put here in the slide. So 1 minus the enhancements or the function of enhancements that I can enhance over the speed up of the enhancements. So what speed up I will get when I enhance the thing. So for this question, S enhancements is 2. F enhancements is 75, which will give me 0.75 as a percentage. Therefore, the overall speed up is S is 1 over 1 minus 0.5, which will give me 0.25, plus 0.75 over 2. All of this will give me this, and this would give me that. That means that for this system, if I am to do what I want to do, I would get an overall speed up of 1.2, 1.6. That is the improvement my computer will improve. It will improve by a factor of 1.6. It's not even reaching 2. So if I look at the cost involved, if I look at the cost involved in doing something, well, 1.5. So at that point, it is upon you to discuss, because over here, you can see that the question makes it a point to tell you about the cost, that the cost of doing it is going to be fivefold of the initial cost of the computer. So let's look at this from a logical point of view. If I buy a computer and I bought the computer for 100 Ghana cedis, they are telling me that because of depreciation, the computer's cost has reduced by 20%, which means that now the cost of my computer is 80 Ghana cedis. Now, if I go and do this thing, I will have to pay 80 Ghana cedis times 5, which is 400 Ghana cedis. It's 400 Ghana cedis worth my computer just increasing by 1.6. That is what we're here to learn today. When we meet again next week, our job is to take a series of questions like this and then discuss them at length, see how we can solve them, see how we can break them down, different questions, different scenarios. Of course, in this slide, at the back of it, we have some questions there for you to try your hands on. I hope you have. One person did it and sent it to me, which I was very proud of him for doing that. So you go to the back and then do all of these questions. You don't have to send them to just for you to try your hands on. But when we meet, we'll have series of questions that have to do with Amdahl's law, and we'll try them because we are face to face. We can see how they are and write them on the board better. Also, next week we'll start learning Boolean algebra. I understand that you people have done Boolean algebra already. Class rep, is that true?
Yes, sir.
So there is no need for me to come to class and teach it again, right? You guys have already done these things here.
Sir, please go over.
My class rep, you have done the laws, the impudent law, the identity law, the condemned, you have done dominance law, you have done De Morgan's law, and you can break down and do SOP.
Let's go over.
No,
sir.
sir.
Yes.
No, sir.
You have not done
Let's
SOP.
go over.
You have not done standard
Just
form
go
of.
over.
Okay, we'll go over. It's not anything. Who was the one who thought, let me call him and confirm if he has done it. If he has done it, I'll do it again. But it's okay. We'll go. When we come, the second half of our lecture will be us starting Boolean algebra. So we'll discuss what Boolean algebra is and how we can use it to do whatever we need to do. Now, the reason why we are learning Boolean algebra is because in our fourth lesson, we'll use the Boolean algebra to construct the CPU and see how we can construct a very good CPU. And then after we have discussed the very good CPU, then we can discuss the fetch decode sequence. How does the CPU go and take information, use the information, run the information? So when we come next week, we are going to go through a series of questions. After we have gone through the series of questions, then we will meet next week. As always, I'll make the video available, and then you would have the video when I'm done, I'll send you people the video so that you can watch and go through the lesson. Is that okay? Before I go, are there any questions? Yes, what's the question, please? So, yeah, what's the question?
Okay, so the example that you gave, the one we just discussed, would there always be a statement that shows that a particular portion of the program cannot be changed?
Yes, there'll always be that scenario. For every question in which you'll be given, you'll be given that's why I want us to do the questions when we meet in class, to be honest. Because there'll be different scenarios that will be presented. And each scenario, the question will tell you the information. It will tell you the enhancement, it will tell you the factor of enhancement for you to then calculate the speed up. It will always tell you. Now, the truth is, it may not always be clear. Sometimes you have to do some work before you get to the enhancement. That's I must be honest. So us doing it in class will be us seeing the different view of them. And remember, the job of this is not to just get the speed up, it's to note if the speed up is worth it. Because if I make a change to a computer and the change I'll make on the computer will cost me 10,000 speeds and it will only give me 5% improvement, is it really worth it? But let's say I do 10,000 and to give me 100% improvement. Okay, but that 100% improvement, will it benefit my work team? So that one day when you are the boss and someone comes to you and says, okay, in our organization, all our computers are 4 gigs. Let's make all of them 8 gigs. On what basis are you making them 8 gigs? How will it benefit you as the organization? How will it make you as the organization better? You can calculate that. And based on that, it will inform your decision if you should go in that direction or not. Are we okay?
Yes, please.
And then we have a question. Are we going to get the chance to develop a computer? We will develop a computer digitally in terms of the board and see how we can put the circuits together to get the best computer we can develop. In terms of building the computer physically, soldering, but we are supposed to have a class where we would have some computers that we put together and develop. Any other questions? Okay, if there are no other questions, then again, God bless you. Thank you for coming. I'll send you this class video so that those of you can go over it, listen to it again. Yes, I sent you the class I had with the weekend. Go over it, listen to it, prepare yourself for it. But when we come next week, as I've told you, the first half of the class will be us solving questions on Amdahl. Second half will be us doing multiple. So we go for the Boolean multiplier, how we can break things down so that we can get better knowledge. Thank you for coming. Enjoy the rest of your day. Bye-bye.
The Momo number.
You may come Max, man, come Momo. That's so dear. Bye-bye.